Good morning, everyone. Happy Friday. Welcome to TVE Happy Math Hour, our weekly interactive math reviews for Math 1314 and Math 1324, presented by Yvette Chuca, Ruben Carrizales, and Albert Isasi. Our session will be starting soon. This session will be recorded so that you may come back to it later if you need, and so others who may have missed out on today's events will be able to come and watch it. Thank you. So now at this time, please mute your mics for best sound experience. Otherwise, the feedback could interfere with information we will be sharing. Ms. Patricia will be sending individual messages to everyone to gather your student ID numbers to sign you in. Without further ado, I'll pass it on to our presenters so that we may begin.
Hello, everyone. Welcome to Friday Happy Math Hour. Hope everyone has enjoyed their week. And so today we're going to be looking at some different topics that you are seeing in both your 1314 and 1324 course. And so we're going to get started at any time. If you have any questions, please let us know. And also, if you feel that your screen is a little too small and you want it to be bigger, if you see my blue arrow here, right on top of it, you should see the little magnifying glass. You can make your screen bigger or smaller. And again, if you have any questions, just let us know. And we're going to get started. So one of the first things that we're going to look at is evaluating functions. And so here they tell us given f of x equals the square root of 3x minus 2, evaluate the following three different problems here. So given that x is equal to 2, x is equal to a, and x is equal to 6 plus h, so we'll do a first. And so here what we want to do is, since we know that x is 2, we can substitute anywhere we see an x with the number 2. So here I have an x, so I'm going to replace it with the number 2. And then we can simplify. So 3 times 2 is 6, minus 2 is equal to the square root of 4, which will be 2. For letter B, instead of the number 2, they want us to replace x with a. So if I substitute a for x, then we get 3 times a minus 2. And 3 times a is just 3a, so we just get 3a minus 2. I can no longer simplify here, so that would be my answer. And then for 6 plus h, we want to replace everything in the parentheses here for x. So wherever I see my x, I'm going to replace it with 6 plus h, and then we're going to simplify. So 3 times 6 is 18. 3 times h is 3h. And then we have our minus 2. And so 18 minus 2, I can combine those, and that gives me a 16 plus 3h. The next function is what we call a piecewise function. And we call it piecewise function because, as you can see, it has two different equations. And if you graph it, it's going to have two pieces on the graph. This equation here, we have to decide which one we want to use, or not want to use, but which one we should use based on the conditions they give us. So for any value of x that is less than -1, that means we're going to use the top part of the equation. For any value greater than or equal to -1, we're going to use the second part of the equation. So the first thing you want to do is figure out if I have f of -4, remember that the -4 here is going to replace your x variable. So we're going to substitute it for x. So we want to decide, will we use the top equation or the bottom equation? So then we can go from there, right? So -4, is that less than 1, or is that greater than or equal to -1? Okay, so it is less than 1, so that means we're going to use the top part of our function. And I like to write it right below it just so that I can keep track of what I'm working with. So now that I know which equation I'm going to use, I'm going to substitute the -4 into every x that I see in my equation. Okay, so I have f of -4 is equal to -2. Instead of x, I'm going to replace it with a -4 minus 1. -2 times -4 is positive 8. 8 minus 2 is going to give me 6. Okay, and so what happens is this information here, your x is -4, and then this result 6, that is your y. Okay, so this is basically when x is -4, our result is going to be 6. So let's try -1. So here again, we decide, should I use the top equation or the bottom equation? So if x is -1, that means that it's going to be equal to -1. So I'm going to use that second equation. And everywhere I see an x, I'm going to replace it with a -1. So I have x squared. I'm going to have my -1 squared plus 2 times -1 and then minus 1. So here my negative is being squared. So -1 times -1 comes out as a positive 2. 2 times -1 is a -2. And then I have a -1. So 1 minus 2 is -1. Minus 1 gives me a -2. And then for letter C, f of 1. So if 1 is going to be greater than -1, so we use that second equation. Substitute 1 for every x. So we have 1 squared plus 2 times 1 minus 1. 1 squared is 1. 2 times 1 is 2. And then we have a minus 1. 1 plus 2 is 3. Minus 1 is 2. Okay, so that was just a, excuse me, that was just a glimpse of how to evaluate a function. The most important thing is that whatever you see in this parentheses here, you want to replace everything that's in there with the variable x, and then we simplify. So the next topic is domain. So domain is going to be used quite a bit in both classes for the whole semester pretty much. So let's talk about domain. Whenever you hear the words domain, you want to think about what are all the x values that are being used to make this graph, for example. So if I was to come up, let me get my pen out really quick. So if I was to pick any x on this x-axis, is it being used to make this graph? So for example, if I pick 5, if I go up, it's going to touch my graph. So I'm using the number 5. If I use 1, it's still being used because it helps me create the graph. If I use -5, notice that I touch my graph here. So all of these numbers are being used to create this graph. Okay. What about if I had a number over here, like say 20? Is that being used to create the graph? So if I was to go up, eventually my graph is gonna it's gonna be part of that graph. And I know that because of the arrows that are on my line here. That means that it's gonna go on forever. And so the domain, which is again, what are all the x values that are being used? So the domain is gonna be all of these x values right here and all of these x values to the left. So the way we write that answer is the domain is all real numbers. If they ask you to write it in interval notation, let me get the pen out again, then we can say that the domain is going to go from negative infinity, which is everything over here on the left side, all these values, all the way to positive infinity, which is going to be everything over here. Okay. But we're not always going to be given a graph, so we need to be able to figure out what the domain is if they give us an equation. So something I like to tell my students is to really think about the following questions. If you're looking at an equation and you see a fraction and the denominator has a variable, then that should be a red flag, and that means that you are going to have a restriction in your domain. So there's going to be some of those x values that you cannot use because in the denominator you end up with 0, and we cannot divide by 0. And you'll see some examples here in a second. The other question that you can look at is if you have a square root or an even root in your function, then there's going to be some restrictions because we cannot take the square root of a negative number. And then the third one, which you don't really have to worry about till you get to chapter 3 in 1324, and I think, I'm not sure what, in 1314 it's chapter 3, 1324, I'm not sure. I don't remember what chapter it is, but you don't have to worry about it. But if you see the word logarithms, then you know that there's going to be some restrictions. So if the answer to these three questions is no, then your domain is always going to be negative infinity to positive infinity. So let's go ahead and go to try some of these. Okay. So find the domain of each equation below. So if we look at the first one, this one here, A, let's ask ourselves those questions. Number one, do we have any fractions with the denominator as a variable? So that answer is no, there's no fractions. Do we have the second question, do we have any square roots that are involved here with the variable inside of the square root? The answer is no. Okay. Do we have any logarithms in here? And the way you know if it has a logarithm is that it's going to say um, the word log in it. So the answer is no. Since I was able to say no to those three things, then that means that for letter A, my domain is going to be from negative infinity to positive infinity. Okay, so I kind of jumped the gun here. Let me go ahead and click through this. Okay, so again, the answer for letter A is going to be from negative infinity to positive infinity. And in fact, this is just a line. And so the line is going to use all of the x's and use all of the negative x's and all the positive x's. Okay, so here's a picture of my graph. Let's go to B. So for B, do we have any fractions? No. Do we have any square roots? No. We have a square, but that's not the same as a square root. So that's a no. Do we have any logarithms? And that's a no. So my answer is going to be negative infinity to positive infinity. And later in these two courses, just by seeing the equation, you're going to realize that it's a parabola that opens upward. And so it's going to use all the x's and the x-axis. Okay, so here's a picture of that parabola. So this is going to go on forever using all your x's. Let's try letter C. Find the domain of the equation. So here's letter A. Y equals 1 divided by x plus 4. So my first question is, do I have any fractions such that the denominator has a variable? So the answer to that is yes, we do. Since we have a fraction and x is in the denominator, what we can do is we're going to set x is equal to 0. And if you notice here, if x is 0, I cannot divide 1 divided by 0. Okay, so we cannot divide by 0. Therefore, the restriction here is that your domain can be any number except for that 0. So how are we going to write this number? And let me go ahead and just draw a number line to help us see it. So here's the x values, right? So here's 0, 1, 2, 3, and so on. And then on the left side, -1, -2, -3. And so here it's telling me I can use all these negative numbers and all of these positive numbers except for 0. So we have to figure out a way to write this. So we can say that our domain is going to be negative infinity, negative infinity. Oops. Let me go back. Okay, so negative infinity to, I'm trying to get my pen to work, all the way to 0 here, right? So I'm going to put 0. And then you could be thinking, well, you just said we cannot use 0. So if you use a parentheses, that means that the number 0 is not included, okay? But we have to keep 0 there because there's a bunch of little numbers that are really close to 0. Let me highlight some, for example, like these numbers in there. And we want to be able to capture those numbers as well. So we use 0 and put a parentheses, and that tells us that 0 is not included. And then we're going to use this symbol, which represents union. And then we start from 0 and we go to positive infinity. So our domain is going to be this in interval notation. In words, we would just say all real numbers except for 0. Okay, so let me just click through that. So let's try the next one. I'm going to plug in my computer, but as you can see here, the question is, do you have any fractions? And then the answer is yes, we have a fraction. So since we have a fraction, we set the denominator equal to 0. So that's going to be x minus 6 is equal to 0. And then you want to solve for x. So if we solve for x, we get 6. And so in words, my domain is going to be all real numbers except for the number 6. So how do we write it in interval notation? And so if it helps, you can draw a number line. So the way we're going to write it is from negative infinity to positive 6, union 6 to infinity. So again, the important thing here is that we're using a parentheses to represent that 6 is not part of the domain. If it was part of the domain, then we would use a bracket, which I think I have an example soon. So here are the graphs. That way you can see what the graphs look like for these two problems that we just did. And you can see where the domain is and what number is not included. So like here, we don't include 0. And the graph is going to get closer and closer, but it's not going to go to 0. And then the same thing here with this problem. Let me see. So this one's reversed there. Okay, so let's try this one. Do you have any fractions for letter A? There's no fractions, okay. Do we have a square root? So here we have a square root. And so that means that there's some restrictions that cannot be used as part of our domain. And so if we continue to find those, what we're going to do is we're going to set the radicand, and the radicand is just whatever's inside the square root. And we're going to set it greater than or equal to 0. And then we're going to solve for x. So in this example, x is greater than or equal to 0. And since it's already solved for x, this is actually going to tell us that the domain begins at this point. Okay. So earlier, it was giving us the restriction. This is telling us where it starts. So here we're going to end up with the domain going from 0 to infinity. And so let me just draw this first number line. Okay, so here's my number line. And here's some numbers. So here it's telling me the domain is going to go from 0. And then you can use all of these numbers are part of the domain. Okay. Since I can use 0, I'm going to go ahead and use a bracket. Okay, so here I'm going to represent that I can include 0 with this bracket here. So my domain is from 0 to infinity. So again, all of these numbers, if you put them in for x, they're going to be positive in the square root. let's try B. So here we have no fractions, but I have a square root. So that means that I need to take my radicand, which is everything inside of the square root, set it greater than or equal to 0, and solve for x. So if I subtract 5, I get x is greater than or equal to -5. And what this is saying is any number that you use for your domain has to be greater than -5. So if I had a -6, for example, -6 plus 5 would give me a -1 in here, and I can't take the square root of a negative number. That's why it's important for it to begin at -5. So it's going to go from -5 to infinity. Find the domain of each equation below. So this is just showing you the pictures or the graphs. So here's the square root of x. So it starts at 0 and it goes to infinity. And then this one starts at -5 and it goes to infinity. Okay, let's go to the next part here. Evaluating functions graphically. Use the graph of the function to find the domain and range of f. Use the graph to find the indicated values. Okay. So first they want us to find the domain. So again, the domain is going to be all the x values that are being used. So I have a question for you, and you can put your answer in the chat if you like. Am I using -5 as part of my domain? What do you guys think? Is -5 in our domain? Does it help me create my graph? No, right? Because if I go up or if I go down, I don't even touch my graph, right? And I can assume that it will eventually, because this graph, if you notice, it doesn't have any arrows pointing that it's going to go like further up, right? So here, -5 is not going to be part of my domain. What about this number here? What about 2? What do you guys think? Let me go ahead and yes, right? Because it's going to touch it. So if you notice here at -2, if I go up, it helps me create my graph. So that's going to be part of my domain. And on this side, if I go up, then -2 is going to get me here. But if you notice the difference here, on -2, I have a parentheses. And the reason I have a parentheses is because -2 is not part of the graph. And we know that if it has an open circle like this. And at +2, since it's a filled circle or it's shaded, then we use the bracket. Okay. So the domain goes from -infinity to positive, I'm sorry, from -2 to +2. Now the range is going to be all the y values that are part of the graph. So instead of the x values, now we're looking at all the y values that are part of that help us make this graph. Okay, so if I choose this y value, this is not part of my range. But what is the smallest y value that is part of my graph? The smallest one would be at this point here, and that point is -4. So I'm going to go from -4 all the way to +5, because at 5 I can make my graph here. Okay. You always want to write the smallest number as well when you're looking at domain and when you're working with range. Okay, now let's try these, evaluate these. So here it's saying when x, try to find f of -1. So remember, inside of the parentheses, that's your x value. And so we go to -1 for x. So here's my -1. And we need to know what the y value is. So we can either go up or down until we get to the graph. So I'm going to scroll down. And my y value here is going to be -4. Okay. F of 0, here's my 0 for x. I'm going to go down. Okay. f of 0, here's my 0 for x. I'm going to go down, and this y value is going to be -3. And then we have f of 1. If I scroll down, we are going to end up at -4 again. And then f of 2, what is f of 2 going to give me? Any answers for f of 2? So f of 2 will be, so here's my 2. If I scroll up, then my graph touches at 5. Okay. So if we go at 2 here, you need to go up to see where it touches the graph. And it's kind of hard to see, but if we scroll, like if we were to zoom in, it's going to be at 5. So I could see why one of you said 3, because it almost looks like it's at 3. Okay, so that was really hard to see. Let's try this one. Use the graph of the function to find the domain and the range. So here we need to find the domain. So what is the smallest number on the x-axis that is being used to make this graph? What do you guys think? So -5, is that my smallest number to make this graph? So it touches the graph. But what does the arrow tell me? It tells me that this is going to go on forever. So that means that I'm going to be using all these negative numbers over here. So my domain is going to be from -infinity all the way to, I get to 1 here. 1 is still being used, even though if you notice here I have an open circle. It's not used for this part of the line, but it's used for this one. And then if I continue, I'm still using all of these x's. So my domain is going to go from -infinity to +infinity. So I'm using all of these x's. Now for y, my smallest y value is -2. But I'm not using -2 because it has an open circle. So I would use a parentheses. So -2. And then all of these y values are being used. Because any y value I pick here, if I go across, I'm going to land on the graph. Okay, so my range goes from -2 to +infinity. And now let's try this one. So f of 2 is going to be equal to, what is my y? 0, right? So here's f of 2. F of 1, so here's my 1. Is it 0 or is it -2? So it's going to be 0 because that's where the shaded point is, right? It's not going to be here because this is open, which means that 1 is not used for this right here. And then f of 3 is right here. So if I go up, it looks like it's -2, or I mean +2. And then f of -1 is on this side. And if I go up, it looks like it hits at 2 as well. And so Mr. Carizales is going to go over combination of functions next.
Thank you so much, Yvette. So now that we've reviewed a little bit of how to evaluate functions, let's look at the combination of functions. And what does this mean? Technically, we're going to be doing basic math operations with functions. And those basic math operations of functions are going to be adding, subtracting, multiplying, and dividing functions. So let's get to it. Let's go ahead and start. So um, let's say that we're given these two functions. F of x is equal to 3x minus 7, and we have g of x is equal to 4 minus x. So let's start with A. I want to add f plus g of x, and that's how we read it. But technically, what I like to tell my students is, let me write it as what they're asking me to do. They're really, even though the syntax might be a little bit strange, what they're really telling me is to add function f with function g. So if I do this, if I write down what they're asking me to do, it allows me to just substitute and make the math really easy for me. So this is the syntax that you'll see in your homework, but this is what you're really going to be doing. You're going to be adding f of x plus g of x. So if I substitute what f of x and g of x, I can go ahead and simplify and solve what they're asking me to do. So here, f of x is 3x minus 7 plus g of x is 4 minus x. Now comes to simplifying, means let me combine any like terms if I can. So see, I have a 3x and a minus x. So those two can be combined to give me 2x. And then I have a minus 7 with a plus 4. So since they're opposite signs, I'm going to subtract and keep the sign of the larger number. 7 minus 4 is 3. Since 7 was the bigger number, my answer is negative 3. So f plus g of x is going to produce 2x minus 3. Okay. Subtraction would be the same thing. The syntax here is read f minus g of x, but what they really want me to do is subtract function f of x with function g of x. So I'll go ahead and substitute what these two functions are. So we have f of x again is the same, 3x minus 7, but now I have a minus. Since I have a minus, I went ahead and put a parentheses with this other function because this subtraction means that I have to subtract with all of this. So to simplify, and before I can start combining like terms, I need to distribute this negative symbol, or you can think of it as a negative 1 out here. So when I do that, a negative times a positive 4 will give me a negative 4. A negative with a negative is going to give me a positive, so that's going to give me positive x. So now I can combine like terms. I have a 3x with an x, that's going to give me 4x. And then I have a negative 7 with a negative 4. Since they have the same sign, I'm going to add and keep the sign. 7 plus 4 is 11, and they were both negative, so it's in negative 11. So my result, or my answer, of the subtraction of these two functions is 4x minus 11. Okay, now let's go to multiplication. I'm going to do the same thing. The syntax, or what the book is asking me to do, is fg of x. So as we know, when two things are next to each other, they don't have to put a symbol. We know that they're being multiplied with each other. So let me just substitute that. So what they want me to do is just multiply f of x with g of x, and I'll substitute the functions. F of x is 3x minus 7. G of x is 4 minus x. And to simplify, all I have to do is FOIL, right? I have to distribute this 3x with the 4, the 3x with the minus x, and then the minus 7 with the 4, and the minus 7 with the minus x. So when we do that, we have 3x times 4 gives me the 12x. 3x times a minus x gives me a minus 3x squared, or to the second power. We have a negative 7 times a positive 4 gives me a negative 28. And a negative 7 with a negative x gives me a positive 7x. So we will see if we can combine like terms, but there isn't, right? Oh yeah, we do. We have one like term. We have a 12x and a 7x. Those are our only two like terms. So we can combine those to have 19x. Now, the order when you put them in on your computer, doesn't matter, but we like to be standard. We always like to put our polynomial here in descending order. So again, we have minus 3x to the second power plus 19x minus 28. And this would be my answer. All right, let's do the last one. Again, what this operation is telling me, I want to divide f by g of x. Okay, so technically, that's all it is. I want to divide f of x with g of x. So now I'll substitute each one. Again, f of x was 3x minus 7. G of x was 4 minus x. Now, can I simplify these? Is there anything that I can factor out from the top or from the bottom that would allow me to cancel? So the answer is no. So technically, this was the easiest problem. That's the answer. F divided by g of x is just 3x minus 7 over 4 minus x. But on your homework, because this is a fraction, and because we always want to practice our domain and how we write things in interval notation, they're going to ask us, what is the domain of this result of f divided by g? And the reason, again, why they're asking us this is because, as Ms. Chuka explained earlier, we always want to look at results. And if our result is a fraction or a square root, we're going to have restrictions on our domain. So will we have a restriction on this one? Well, the answer would be yes, right? Because we have a variable x on the bottom that could make this denominator all equal to 0. So again, if you don't see it, what we want to do is we would set the denominator equal to 0. 4 minus x is equal to 0, and then solve for x. So the first thing I would do is I would subtract 4 on both sides. So that would give me negative x is equal to a negative 4. But again, I just want the x. So then I would multiply by a negative on both sides. So the negative 4 would become a positive 4. So what this is telling me is that if x is ever equal to 4, I'm going to get a 0 on the denominator. So the domain in words is all real numbers except for the value 4. But in interval notation, we would write from negative infinity to 4. Sorry, we forgot the comma there. Again, we will use parentheses to say that we're not including the 4. And then the union means the and, the other half, right? Starting from 4 to positive infinity. So again, this is to practice our domain. All right, so let's look at these two more functions to practice our combination of functions. So we have a function x to the second, or x squared, and then we have g of x, which is equal to 2x minus 5. So let's get to it. Again, I'm going to rewrite this as far as what they're asking me to do. They want me to add function f of x with function g of x. I'll substitute what these two are. F of x is just the x squared. G of x is the 2x minus 5. And simplify. Simplify means can I combine like terms? So my answer for this one is no. There's no like terms that I can combine. So that's going to be my answer. Just x squared plus 2x minus 5. All right. So there it is. Let's go ahead and do the subtraction. F minus g of x. Again, they want me to subtract function f of x minus g of x. Let's go ahead and substitute what these are. So we have x squared. Again, because we have a polynomial on the right, let's go ahead and put our parentheses so we can take care of that subtraction. So now to simplify, we need to distribute that negative symbol, or like I like to say, there's a negative 1 in front of there. So we have x squared, a negative with a positive 2x is a minus 2x, a negative with a negative is a positive 5. So we have x squared minus 2x plus 5. And now we ask our question again, can we combine like terms? And again, the answer would be no. There's no like terms that we can add. So our answer is going to be just x squared minus 2x plus 5. All right, so that is our answer. Now let's go ahead and do the product, or the multiplication. Again, we want to multiply f times g of x. So this would just be f of x times g of x. Let's substitute what these are. F of x is x squared. G of x is 2x minus 5. On this one, to simplify, I need to distribute just the x squared to both of these terms here. So x squared times 2x is going to give me 2x squared. I don't know why we have that. Let me see. Oh, here we go. The x squared times the 2x is going to give me a 2x cubed. 2x squared minus 5 is going to give me a minus 5x squared. Now again, these two are two different terms. This one's a cube, this one's a square, so I cannot combine like terms. So this would be my answer. Okay. All right. So again, f times g of x is just, it keeps repeating. So let's go ahead. Let me move to, again, this line shouldn't be here because this is our final answer right here. So now if we look at the division of f of g of x, they're telling me to divide, f of x by g of x. Let's go ahead and substitute. So f of x is x squared. G of x is 2x minus 5. Again, we want to simplify. Can we simplify? Is there something that I can factor from the top that I could also factor on the bottom so they can divide out? Well, the answer is no. So there's nothing that we can factor out. They're in their simplest form. So this is going to be my answer for the division of these two functions. X squared over 2x minus 5. But then again, because we have a fraction, they're going to ask us to. So just like before, if you don't see it, go ahead and set the denominator equal to 0. 2x minus 5 is equal to 0, and solve for x. I'm going to add 5 on both sides, giving me 2x is equal to 5. Divide by 2 on both sides, so x is equal to 5 halves. So again, in words, the domain is all real numbers except for the value 5 over 2, or when x is equal to 5 over 2. So in an interval notation would be from negative infinity to 5 halves, parentheses, not including that 5 halves, union, oh, these are backwards, okay? It's supposed to be, let me pull out my pen really quick. This should be over here, and this should be over here, okay? So it's 5 halves, comma, to, and not negative, it's to positive infinity. Here, let me X this out better. Let's write it. So the answer is 5 halves. That's union from 5 halves, the continuation, to positive infinity. This is what's supposed to be, okay? All right, so this is my answer in the interval notation. All right, let's go ahead and do one more example. Here we have time. We have f of x is x squared plus 3, g of x is the square root of 2x minus x. So again, I'm going to go fairly quickly. Again, this is all of the same. We want to add f of x plus g of x. On here, we want to simplify, but if you see here, there's really nothing to simplify. Again, you can input this answer like this on the computer, but we like to reorder it. We always like to put our constants, just our numbers at the end, and we can write it like this. Again, you don't have to. Let's do the subtraction. F of x minus g of x. Again, I'm going to substitute those values on this one. Again, because of that subtraction symbol, I have to make sure that I distribute to my other function. So again, I'll distribute the negative to the square root of 2 minus x, which is just minus square root of 2 minus x. And again, that is perfectly the answer that I can input on the computer. But if you like, again, you can rearrange it or leave it like that. Okay? So let's go ahead and do the multiplication of f of x with g of x. So we have x squared plus 3 times the square root of 2 minus x. So again, we're going to do the simplification. And I believe you can leave this answer like this. Okay. Now, I believe the computer will also accept x squared times the square root of 2 minus x plus 3 times x, the square root of 2 minus x. But again, you can leave it just like that. And then the last one, the division of the functions, f divided by g, we just substitute. So we have x squared plus 3 divided by the square root of 2 minus x. So again, our homework is going to ask us, we can't simplify, right? Again, we cannot factor, so that's going to be our answer. But the computer is going to ask us for the domain of this division. So we never want the denominator equal to 0. So if we don't see it, let's set it equal to 0. So we have the square root of 2 minus x is equal to 0. The first thing that I'll do to solve for x is take the square of both sides. And it's going to give me 2 minus x is equal to 0. Give me 1 second. There we go. Okay. Then I'm going to subtract 2 on both sides, then multiply by negative on both sides, which is going to give me x is equal to 2. Okay. So again, there's 2 ways of doing that. This is doing it just with our fraction, but again, we have our square root, right? Our square root is going to be all these values from negative infinity to 2 for our interval notation. All right, so at least composite functions that my partner, Mr. Isazi, will take over.
Hello, students. My name is Mr. Isasi, and I'm going to be doing composite functions. see here. Okay, here we go. Okay, it says find f of g and g of f and g of g. What we're doing here, they give us a function f of x equals to x plus 4 and g of x equals to x minus 3. So we're going to apply the definition. This is the definition here. For example, f of g is equal to f of g of x, which means I'm going to go to my f function and I'm going to plug in the g function. Let me show you what I'm talking about. You see, so I went to my f function and I'm going to plug in x minus 3 for every x on my f function. You see, so I plugged in the x minus 3, I plugged it in for the x. So that's going to give us x minus 3 plus 4. And then now we do is simplify. It's going to give us x plus 1. So the composite function f of g of x is equal to x plus 1. Now let's do b, the composite function of g of f. Okay. So g of f, now it's like reverse. So now we apply the definition. So I'm going to go to my g function and I'm going to plug in f of x, which means here in green is a g function. So I'm going to plug in x plus 4 for every x on the g function. Okay, like it says here, I'm going to substitute f of x into the parentheses and then I'm going to evaluate. So therefore, we're going to go to my g function and I'm going to plug in x plus 4 for every x. I don't know if you guys can see my mouse, but here's what I'm talking about. You see, this is my x, right? So I'm going to plug in x plus 4 for every x. Here's my x plus 4. Okay, so if I plug it in and then we evaluate it, it's going to give us, or simplify, it's going to give us x plus 1. So the function g of f will give us x plus 1, and also the function f of g also gives us x plus 1. This doesn't happen every time, so don't assume that that the function f of g, right, f of g is equal to g of f. This happened because, I mean, the way the function was set up, but most of the times this does not occur. Okay, so like I said, don't assume that that you're going to get the same answer as we did here and as we did here. Okay, now let's continue. Now we're going to do part C, which is g of g. So I'm going to go to my g function, right? This is my g function here. See, this is my g function. Let me, that's my g function. So I'm going to plug in, let me go to the next one here. I'm going to plug in x minus 3. I'm going to plug in x minus 3 right there, right? I'm going to plug in x minus 3 in there. So it's going to give us, let me get the marker again. It's going to give us x minus 3, right? Which I plug it in there. Minus 3, which is going to give us just x minus 6. So g of g will give us x minus 6. This is supposed to be a g here, guys. Okay, I made a mistake here. This is supposed to also be a g. Okay. As I continue, if you have any questions, just put it in the chat, and then I can answer your questions if anybody has any concerns or any that you want me to clarify. Now here's another example. Okay, we're going to do the same thing. We're going to find f of g, g of f, and g of g. So again, for a part, we're finding f of g, which means this here is a definition how to evaluate f of g, which means I'm going to go to my f function. Okay, let me mark it down. I'm going to go to this function here, right? And I'm going to plug in x minus 2 for every x. Right?
Alberto, we have a question in the chat.
Okay. Let me. Could you ask your question, please? Let me see what the question is. Okay, let me go here. Okay, so Anai says, so we have always to always change to the end of the x value. So we have always. What do you mean? I mean, Anai, I don't really understand what your question is. Maybe you can get on the mic and maybe you can ask it if you don't mind. Or let me see if I can explain like a little bit better. Okay. Okay. Again, let me start here again. Okay. So here, right, we're finding f of g. Okay. Okay. That's okay, Anai. Okay. So let me see if I can explain it better. Okay. And if you understand it, just put it in the chat. So I'm going to apply the definition. This is my definition. Okay. It's in blue. Which means now I'm going to go to my f function, you see, because that's in the outside. So I'm going to keep the f in the outside, right? So I'm going to go and plug in x minus 2 for every f, because g of x is equal to x minus 2. So all I'm doing here is plug in x minus 2, right, for g of x, right there. So then I'm going to go to my f function, and I'm going to plug in x minus 2 for every x. So then I'm going to go here for the x function. I'm going to plug in the x minus 2, which I just did right here. And then to square it, it's going to be x minus 2 squared. So x minus 2 times x minus 2 is going to give us, right, if we do the FOIL, x times x will give us x squared. X times negative 2 will give us negative 2x, and negative 2 times x. Let me put it here in the writing, okay, because I don't think you can see my mouse. So again, x times x will give me x squared. X times negative 2 will give me negative 2x. Now, x times negative 2 will give me negative 2x. Now comes the inner term. Negative 2 times x will give me negative 2x, and negative 2 times negative 2 will give us a 4. Now we get to combine like terms. So these two are like terms. So then it's going to give us x squared minus 4x plus 4. That'll be the result. Anai, did that make sense? Okay, I see. Okay, I see that answered your question. You're welcome, Anai. Okay, now we're going to do g of f. Okay, so again, we're going to apply the definition. Again, this is a definition of g of f. So then I'm going to go to my f function, right? This is my f function here. I'm going to plug in x squared inside there. So it's going to be g of x squared. Okay. Now I'm going to go to my g function, and I'm going to plug in x squared. I'm going to plug in x squared where the x is. You see that we did that, so nothing can be combined. So that's my final result, x squared minus 2. So g of f will give us x squared minus 2. Okay, now let's find, so this will be g of f, x squared minus 2. Let me see here. Now we're going to do g of g, okay? So this is part C here, but it says part B, so it's part C. So we're doing g of g. So again, this is my definition again. Apply the definition, which means I'm going to go to my g function, right? And I'm going to plug in g of x right there. You see, so I'm going to plug it in here, my x minus 2. Okay, again, let me, I plugged in I plugged in x minus 2 inside the x. That's what we have, x minus 2 minus 2, which will give us x minus 4. That'll be the g, the composite g of g will give us x minus 4. Okay, now let's do another example. Again, this is f of x is equal to the square root of x plus 4, and g of x is equal to x squared. Here they want us to find f of g, or f composite g, g of f, and find the domain of each function and each composite function. Okay, so let's do that. Let's do first the a part. So again, this means that I'm going to go to my f function, right? I'm going to go here and I'm going to plug in g of x there. which means I'm going to plug in x squared where the x is. Okay. You see, so this is my result, which would be the square root of x squared plus 4. Okay, so now we're looking for g of f. So again, we apply the definition. Okay, now, which means, right, so this is f of x. So f of x is the square root of x squared, the square root of x plus 4. So now I'm going to go to my g function, which is this one here, right? I'm going to go here and plug in the square root of x plus 4 for every x. So I'm going to plug it in there. So the square root of x plus 4 squared, these will cancel, right? The square root will cancel with the square. So it's going to give us x plus 4. Okay, now let's see here. Okay, now let's do here the A part. Find the domain of f of g. So the domain for f, right? The domain for f, like Yvette and Ruben said earlier, that we have like a radicand or like a radical, we're gonna get the inside and let it be more than or equal to 0. So we get the x plus 4, let it be more than or equal to 0. So x must be more than or equal to -4 because we subtract 4 to both sides. So this is the interval notation. It goes from a bracket, -4 to infinity. Now let's get the domain of g of f. Here, the domain of g would just give us, this is g here, right? So this is not like a fraction, right? This is not like a fraction, nor a radicand, nor a log. So it'll be all real numbers. That's where that comes from. Okay, now the domain of g of f of g. Okay, so here, this is what we're going to do here. Okay, we know that the domain of g of f of g will give us this part here, right? But this will give us, here it's going to be all real numbers. Why? Because this one doesn't have a restriction because it's a plus. If it's a plus, right, if we let that be more than or equal to 0, it's going to give us x squared is more than or equal to -4, right? It's going to give us like this. Let me finish up. I know we need to go. Right, it's going to give us like this, right? Right, so x squared is more than or equal to -4. And then, right, if we take the square root, we cannot take the square root of a negative number. So this one doesn't have a restriction. So now it says consider the domain of g. The domain of g is all real numbers. So then the domain of f of g will give us, you see, it's where these two intersect. So it'll be all real numbers. So that's my domain for part A. Let me see here. Let me go to the next one. I know, guys, it's already 12. Should I just continue? Let me see here. Okay, okay, guys, I'm just gonna continue, okay? I'm just gonna continue. Okay. Okay, now, guys, so let's go to the next one then. Okay, let's see here. Okay, guys, so now I'm gonna be doing f of g and g of f. And again, f of x is equal to 1 over x, and g of x is equal to x plus 2. So I'm going to be doing f of g and then g of f, and again, find the domain for each composite function. So let's start with f of g. So here, f of g, let me get the marker here. So I'm going to go to my g function, right? I'm going to plug this in. For every x. So I'm going to plug that in right there. That's what that means, right? Because g of x is equal to x plus 2. So I'm going to plug it in where the x is. That'll be my next step. Okay, so it's going to be 1 over x plus 2. Okay, now this is b part. I'm going to find a g of f. Okay, again, let me see here. So I'm going to go right to my g function, and I'm going to plug in 1 over x for every x on my g function. So I'm going to plug that in right there where the x is. Okay, let me see here. Okay, let me continue here, guys. Okay. So you see, so I plug it in there, so it's going to give us 1 over x times x plus 2. Okay, now, guys, I was informed that we need to go, guys. Okay, because it's already past time. Okay, I'm sorry, and I hope all this was kind of helpful to you guys. And I mean, next time we'll try to finish it in an hour because I believe we're under an hour of under an hour schedule. Okay, like Ms. Yuka said, you guys can download the PowerPoint and look at it at your own time. And then if you have any questions, you can come to us for tutoring, and we can help you. Okay, my apologies. Thank you, guys.
To
Thank you,
download the
Miss.
PowerPoint, I'm sorry, to download the PowerPoint, right here where my arrow is, just there's a little box with an arrow pointing down. Just click on that and you'll be able to download it.
Thank you, Ms. Chuka and Mr. Carizales and Mr. Isasi for your wonderful presentation. As Ms. Chuka said, you can download it right on the top corner, the right corner of the screen. We do want to remind you all about our previously recorded sessions, which are available on YouTube playlist. This session will also be available on the playlist later today. Also, linked is a short survey to help us improve our Tejano virtual event session. Please take a few minutes to fill out that survey. And before you leave, guys, I want to be able to share. Let me go ahead and stop this. Oh, okay. Is that what we need? Okay. So I want to go ahead and share the Tejano virtual events flyer with the sessions that we'll be having next week. At 1 p.m., we're going to be having the time management later today. And then we'll be back with Happy Math Hour next week at 11 a.m., where in Math 1314 and Math 1324, they're going to be covering the first exam, and it's going to be they're going to be reviewing in these sessions. Our 1 p.m. session next week will be on note-taking with Miss Rose Galindo. And thank you all for coming in today. We hope that you all have a lovely weekend. If you have any questions, please feel free to use the chat box or your mic. We hope to see you again here for Happy Math Hour next week. Thank you.